Hello and welcome to another Elektor webinar. Today's topic is electronics workbench tips and tricks. And specifically today we'll be talking about test and measurement. So we'll explore electromagnetic compliance, analog signal generation, and vintage measurement devices with our special guests. Hello to everyone joining us from around the world. I see the chat is getting busy there. Let's just go through our sponsor today. Thank you to Siglent for sponsoring us. Our Elektor webinar today is sponsored by Siglent. So if you know test and measurement, you definitely know Siglent oscilloscopes. Now, to introduce our special guests who've given us their time today, I'll start off with Saad Imtiaz. He's our Elektor senior engineer. Now, he has a lot of experience in the topic of test and measurement, as can be seen from his articles in Elektor, which touch on everything from ESP32 for measurement and communication, object detection, and even weather measurement sensors. How are you doing, Saad?
Great. How are you doing, Brian?
I'm good, thanks. You're in Islamabad, Pakistan. How's the weather there? It's pretty much right here in Johannesburg, 22 degrees.
Yeah, hot as always. I mean, it's summer here, and the July just started, so probably going to be more hot.
Yeah, we've got nothing to complain about, unlike those Germans. And speaking of Germans, Sebastian from Baltic Labs is no stranger to this channel. He's a notable contributor to Elektor magazine, and with the creative mind behind Baltic Lab on YouTube and a bunch of other places. He has deep expertise in RF and high-frequency engineering, as you will have seen if you joined for our last Elektor Engineering Insights. And he's been illuminating the complexities of analog information transfer since his first contribution to Elektor back in 2008. So he's very adept with DSP and SDR receivers and all that analog stuff. And he conducts innovative experiments with technologies like waveguides and spark gap transmitters. How's it going, Sebastian?
Pretty good. I feel obligated now to complain about the weather, but you wouldn't want to listen, so let's not do that.
No, it's okay. Saad and I can share notes afterwards. Our next special guest is Herr Dr. Thomas Scherer. Thomas Scherer, he first completed an apprenticeship as a telecommunication electronics technician and then worked in the Elektor editorial department from 1980. Now, that's quite a track record. And this is after studying psychology and spending several years in basic research. He has been a freelance writer for Elektor for decades. That's quite a combination, psychology and engineering. He has a large electronics lab, as you can see behind him. And in addition to neurons, he's also interested in electrons. In other words, pretty much anything that has to do with electricity. Guten Tag.
Hi, Brian. Guten Tag. Yeah, you see, I'm sitting in my cellar, so it's cool here. Outside, we have about 5 degrees now. It's very hot in southwestern of Germany today.
Yeah, I can't imagine what your cellar is like in winter, though.
Yeah, in winter, the heating is nearby, next room.
Good to know. And another German, we have a trifecta today, is Alfred Rosenkranzer, who has worked for many years as a development engineer, initially in the field of professional television technology. And since the late 1990s, he has been developing digital high-speed and analog circuits for IC testers. But audio is his private hobby horse, as you'll see a bit later. How are you, Alfred?
I'm fine so far, beside the rest of the cold from the last weekend. But it's getting better now. I'm also sitting in my basement of my house, so it's cool enough here. You see me with a sweater. Otherwise, it's too cold.
Not nice, but I see you've equalized your audio, so it's not all bass with your cold voice. Let me talk about our giveaway here. Today, you'll have the chance to win this book, Tektronix Epic Oscilloscopes, and we're giving away 3 copies of this. It's an illustrated chronicle of technology, TEK, for collectors and restorers, so don't miss that. We'll give away a code word for you to enter, but I'll just give you a preview of the book here from our elektor.com website. It's very well designed. It's graphically very pleasing to look at, and oscilloscopes from way before my time to the present day. So that should be a pretty cool giveaway, especially for anyone tuning into this The giveaway will be there, but we'll talk about that a bit later. So now, speaking of test and measurement, I'll begin with Sebastian, because as you saw, our sponsor today is Zieglant, and I know from his articles that Sebastian has Zieglant scopes, at least one. Is it just one, Sebastian? You're on mute.
My bad.
It'd be good now. Yeah.
Yeah, I have two Zieglant scopes, actually. One really entry-level one, and the one sitting behind me, the STS2104XHD, is a 12-bit scope, which appears to be the headline of the banner as well, 12-bit for every bench, yeah. It's a really nice scope, and yes, as you said, it's been featured on a few Elektor articles, actually.
Well, it certainly looks very comprehensive, beyond my needs at the moment, but you'll tell us more about that.
Yeah, the really cool thing about it is that you can remote control it. You can just type the IP into your browser and you can do everything from there. Now, of course, this is not limited to your local office. I've actually remote controlled various Zieglant devices from the University of Applied Sciences in Kiel from home when assisting someone during their bachelor thesis. No problem, just VPN and control it from remote. Then, of course, which again seems to be the headline of the banner, the 12 bits, what that actually means is a much higher dynamic range. Just as a rule of thumb, 6 dB per bit of resolution. So a regular 8-bit scope, you get about, 48 dB of dynamic range, which already puts you in a difficult situation when you're measuring main supply voltage. Just small EMI noise or anything riding on top of it, you're not going to be able to see. On a 12-bit scope, you're actually getting about 72 decibels of dynamic range. And of course, like most scopes, there's a feature where you get even more enhanced resolution by averaging, like it's not really averaging. Yeah, so you can get up to 15 bits of effective resolution, which lets you look at things that you didn't know were there. Now, on the flip side, you also see problems that you didn't know you have beforehand.
Yeah, or did you care that you had those problems? They obviously were minor.
Well, something to fix, but it's really interesting to see the difference that all of a sudden your waveform looks different. And we all have a feeling for what waveforms should look like, especially in regards of ringing or anything like that. And then all of a sudden you see artifacts and things that you literally did not know about. And it feels wrong at first, like where does that come from? But you get so much more insight to actually fixing those things.
Well, I'm going to bring up the rest of our guests, Alfred and Thomas and Thad, just so that we're not just having a two-way conversation. But I'll stick with you, Sebastian. Yeah, go ahead.
Can I ask a question to Sebastian? So I have a 12-bit resolution oscilloscope, and I think one of the most important things is I have a big screen, 8-inch. But if you have only 8-bit resolution, you only have a part of the screen. Right? So the resolution is not adequate for a big screen.
You mean the effective resolution? Yes.
The screen, yeah. So this is, I think, it's important if you have a big screen or want to put it on a computer screen. You should have more than 8-bit.
That is true. You can see that on the waveforms, especially if you do any FFTs. It looks, you see just these jaggedy edges, those huge jumps, and you don't see them with 12 bits. And even if you use the ERAS mode, where it even enhances the resolution even more, it looks so smooth that it's almost too smooth, and you question everything because you've never seen it that clear before.
Exactly. Look at here.
Yeah.
See noise in 12-bit resolution here. Yeah. Was all.
Let's have a look at that.
Okay. Oh, okay, can do it.
Yeah, I want to see that. I'm not sure if I was seeing interpolation or...
This is noise in resolution.
Okay. Cool.
So,
yeah,
you really can see the noise.
And what is the source of that signal?
Yeah. This?
Yeah. Where are you getting that signal from?
It's from the different environment you have. The gain is very high now. I can collect everything with a wire. So I put back.
Sort of, you could make music.
Yeah, and so on.
So we were talking about electromagnetic compliance, and Thomas, you showed us a power supply for lighting, which has a CE stamp on it.
Yeah,
and yet
open it. I got a parcel from a reader, Elektor reader. He had a power supply where he wanted to for LED chain he mounted on the in his room, and it has about how many watts is this? 15 watts, no? Not so much, but he got you can see it. It has has many levels on it. It's tested from the German TÜV and so on, and it's more a high frequency transmitter for the shortwave because it has 30 kilohertz with square wave with about 30 volts amplitude, which is crazy. Should not be
an unintentional shortwave transmitter.
Yeah, unintentional. Yeah, and totally crap.
Well, I mean, I still have my 1981 computer on my desktop here, which I'm never shy to show off, and that would definitely be picked up on shortwave. You can practically make music with it if you could figure out the right assembly instructions.
Yeah, typically for former computers, you can even get it an ultra shortwave, about 100 megahertz range. You can get it. So
I think it would just mess up the entire shortwave spectrum.
Yeah, when they switch their old computer on, reduced. Quite.
You'll have to excuse us if we talk over each other. We are, of course, coming to you from all over the world, so sometimes there is that bit of delay, but we'll try and work around that. I'm looking at the chat here. Frank de Hout is back from Belgium, and CJ is here from the USA, and everyone else. But good to see Adan Menkis from South Africa, which is where I'm from. So nice to have some local audience here. But now, Sebastian, let's talk electromagnetic compliance, since we were showing off that power supply and the noise it gives off. And there's always noise around you in an environment I'm scared to measure with all the strange lights and LEDs and screens and stuff that I've got going on here. Tell us about the importance of being compliant, because I, as a hobbyist, it's not the first thing on my mind. I design a circuit. Does it work? Yes, great. Into the field, and by the field I mean my local environment. But when you've got to start selling in mass production, how do you go about that?
Even as a hobbyist, you should be compliant because there is rules for that. But as you said, it's usually the last thing we all have on our minds. And the problem is we usually can't see it and can rarely see the effects of it. In essence, there's two primary kinds of emissions. One is radiated emissions and the other one is conducted. What Thomas just talked about is mostly going to be radiated, and you don't see it, you don't hear it, well, unless you have something next to it that's susceptible to it. And the last thing is that we certainly do never think about as hobbyists, I think I can claim, is radiation immunity. That is one thing we never think about, that our device also has to function if an unintended or intended radiator starts interfering with it. Some things we all know is your old mobile phone next to the FM radio in the car. We all knew the call was incoming before the phone started ringing. This is a type of... Yes, exactly. That is one of those. And we still have AM radio stations around, albeit not very many here in Europe. And those are all things that we need to take into consideration. The problem is that there's so many rules and regulations that hobbyists get turned away from it very quickly, because you always have to see, okay, what is the exact norm and rule that you need to look at. But to be pragmatic about it, the first thing is look at it at all. Like, start doing something. Take test equipment, and for instance, here we have, maybe I should start with the screen. No, I won't. This is a line impedance stabilization network. This is one that's primarily for CISPR25 applications, which usually goes to vehicles and stuff like that. When we build stuff at home, the CISPR11 rules would be more applicable, as they are more for industrial and scientific equipment. Regardless how this works, you have your power source gets applied here. You have your device under test, which in EMC is also often called the equipment under test, or EUT. And it, well, I wouldn't say isolates, but it filters RF coming from this side and from this side completely between those ports. So also your power supply will not interfere with your device under test. And then you got this coupled port. There you can hook up your measurement receiver, a spectrum analyzer, or as we'll see in a second, even a simple oscilloscope, just to get an overview of what's actually happening, just to get a starting point. Now, if you show my shared screen, I will show what a listen generally looks like. Let's take that one. This is just from Wikipedia, sources down there. This is nothing but a simple pi low-pass filter. And you can see it's symmetric. It's a reciprocal network, which is very important. And this goes to your EMI receiver and here to the DUT. Now, the one I'm using, and which is very feasible for hobbyists, is made by TechBox. It's called TBOH01. It's a little bit more complicated, but only because it has protection elements in here for overvoltage, even a gas discharge tube and stuff like that. And the most basic thing you can do, I will show in just a second, measuring power supply noise. Let me actually switch cameras. Let's see what you have on. You have the screen, fine. Let's swap over to Sigland.
Cool.
I hope nobody's dizzy now.
Not from this.
Good. Can you see that all right? Yes. So what we're looking at here is the listen. On this side, I have a 100 ohm resistor. Over here, I have a 5 volt, no, it's a USB extension cord for 5 volts that I will plug into one of those power supplies in a second. Can we see that? Yes, down there. And we will see what shows up on the scope. The scope, let's see. Yes, you have the screen shared. So let me do this full screen. Yeah, perfect. So up here is channel 1. This is connected directly to the listen. Down here, there's a math function performing an FFT. Levels is in dBV. Usually for electromagnetic compliance, you use dB microvolts, but you can just add 120 and you're good. And we will see a peak list. Now let me plug in the USB power supply and see what happens. So up there, we already see that there's quite a bit of noise. I'm zoomed out quite a bit right now, but just to get enough FFT bins filled to get quite an interesting picture. This is 4 averages, as it says there, so it'll take a second till the peak stabilize. And we can see that there's 2 large peaks, one around 9 kilohertz, one around 22 kilohertz. So this will be the first step of what we could do at home and how we could see what's going on with our equipment. Now, the next question that's of course interesting, would this be compliant? Is that okay? So if we add about 120 decibels to these values, we're somewhere between 40 and 42 dB microvolt, which would actually be within all limits prescribed. Now, one thing, and that goes back to Alfred's problem, if you look in the rules and norms, there's very specific test setups that you need to use. Like obviously just putting down a listen like this would not be okay. You would need a grounded base plate. The length of the wires is all in the standards and norms. So what might happen is that you actually seem to be compliant, but the way the user will actually use your product in the end will start all kinds of interference, which is something you should keep in mind. You don't legally have to keep it in mind, but you should. Well, that would be the first thing of testing radiated emissions. Now, a listen can be used as kind of an off-label use for all kinds of other setups, for instance, for conducted immunity testing. As you can imagine, if instead of the oscilloscope, we would connect a signal generator and inject a signal, we could also see how the power supply reacts to interference from outside, conducted interference. Typically, you would use a so-called CDN, a coupling decoupling network, but for at-home amateur level experiments, This is absolutely sufficient to simply misuse a listen for that purpose.
Yeah, that looks like quite a bit of noise, and I see it says triggered at the top there. You've just triggered me, because I remembered times when I just couldn't get an HDMI signal to work. I just couldn't. I tried different cables, and then eventually I moved the cable away from the power cable, and suddenly the signal worked.
Absolutely. And the reason I didn't just set this up for this Elektor live stream, now, of course, I rebuilt the experiment because of that. But what actually happened is I had a audio amplifier that worked very well into the ultrasonic range. It's for a different project where I'm using an SDR receiver to receive ultrasound signals, acoustic ultrasound signals. And I was actually charging my phone next to the setup on the bench. And the output of the audio amplifier was basically representing that plus 100 decibels. So it was extremely noisy. I just couldn't see what is going on. Like, there was obviously no useful audio signal coming through. And then I unplugged my phone, went outside just to clear my mind of what's going on, just reset, and surprise, surprise, the noise was gone.
Well, yeah, came as a surprise to me too, especially with, digital. You can't see the noise. Back in the analog TV days, you would see when you got closer to the noise source, but now it just stops working, or it works intermittently. What would be a good way to measure that kind of noise in your environment? An SDR with some sort of antenna?
Yes, SDRs are actually very good for that. Let me see. I have some pictures from university. Let me see what I can actually show. Let me get the screen sharing smaller. So, well, this is going to look a little bit funny, but sure, let's show it, because someone, that definitely wasn't me, okay, well, I'll admit it, put a chicken inside of the measurement antenna. I'm not sure if you can... Yeah, that it's like a dog toy that squeaks, and it's one way to drive professors nuts when you're bored in class. This is a biconical antenna, and here's a logarithmic periodic antenna. You do not need anything like that at all.
I'm not sure we're seeing the correct tab there.
Oh, you're right.
Still looking your
Apparently, I have
output.
Yes, you're right, because I don't have the screen shared. I have that particular tab shared. So give me 1 second. Present and share screen, whole screen, that screen. Now let's try again. Where did the picture go? It's gone. Let's take that. Can you see that now?
I think you got it. Yep.
Okay. So here's a biconic.
Chicken. I thought you meant to. Yeah. I thought you were microwaving an actual chicken.
No. And we had to actually justify in the lab report how that didn't interfere with the measurement. But this is just an example of a professional setup. This is a biconical antenna, and here's a logarithmic periodic antenna, and this entire thing is inside an anechoic chamber. Now, obviously, that's nothing for the hobbyist. A simple loop antenna is sufficient, and I'm only mentioning this because it's our sponsor. Yes, you could use, of course, a what's it called? A software-defined receiver, of course, but the Siglent spectrum analyzers are actually, hang on, let me bring up this picture. I'll explain in a second what this is. Not only do they have an EMI option, and there's a free trial if you want to try it out, but they actually work with most accepted EMC compliant softwares like EMC View, Readymation, and stuff like that. So if you have one of these, and they're certainly affordable for hobbyists, then you're all set. A software-defined receiver, of course, works as well. On a side note, since I do have it open, what this thing here in the middle is called a TEM cell, a transversal electromagnetic wave cell. It's basically a coax cable with the inner conductor, the outer conductor, but split open in a way that you can put devices under test right in there. By the way, it should be down there, but who's paying attention in class, right? It's terminated with a 50 ohm load here, and this goes directly to your measurement receiver. Now, these are quite expensive, but as you can imagine, if you're handy, you can build these on your own. It's just a little bit of folded sheet metal, In the middle, you can use standard FR4 material, and you can build yourself one of those. You just toss the equipment in, hook it up to your measurement receiver, and you get an overview of the radiated emissions.
The shape of the chamber?
Yeah, it's basically, here it's a coax with 50 ohms, and this is just spreading it open. And here we still have, well, technically we have a free wave impedance in here of 377 ohms, but this is the wave impedance down here. What it really does is it takes the free room impedance of air and space and just translates it down back to 50 ohms. It's symmetrical on both sides. You can also use it for injection. Again, you could also apply a signal generator to the side and see how much RF blast your DUT can handle. This is something that's easily achievable at home. Then another thing I wanted to show from that particular lab.
I have one question to this thing. Are the dimensions available as a PDF or so? Would be interesting.
Yes, absolutely. You can find them for free on the internet. There actually is a bunch of people that build their own because they're such useful tools. I do not have a link handy, but if you Google it, you will find something like that. There's a few people that build them on their own.
What name or what word to Google?
TEM cell. I'll actually type that in the chat like so for everyone to see. There we go. Now it should be in the chat.
There we go.
Okay.
And then there's two more things I wanted to show, because now we've shown some interference, but what we haven't shown is what we can do on an amateur level. I don't want to hog all the time, so I'll be done in a second. Here is a, albeit not norm and standard compliant test measurement setup. Here's a higher voltage listen. There is a DC-DC converter. Here is a variable load. And if I zoom in, that's the nice thing about the Cyclant SVA with the EMI option. As you can see here, there's limit lines in there, and it'll give you markers. They are not standard peak markers. They'll tell you where you're non-compliant. So you can identify frequencies. In this case, it's around 330 megahertz to about, it's around about 1 megahertz is where the peak is. So once you've identified that, that's only half of what you need to know. You kind of need to do anything against it. Not anything, something against it. Where is that picture? And with that, I'm going to mention Workbench. They have these kits. They are, there we go. Then we have a picture. Yeah, that's the one that we built. So what you get in this kit is this base PCB. There's a few different variants, and you get a few standard components. But what you also get with it is a booklet that shows you standard frequency responses of different filter variants. So you can really just, even if you don't know anything about it, you can see where do I exceed my limits, and then look in the given frequency responses, assemble the filter board, which obviously is intended for main supply, but you can use it for DC as well, which we did. And just assemble it, hook it in between your DUT and your power supply or the source of radiation. And then if we measure again with the filter in line, once I find it, my folders always disappear. This will, yeah, there we go. Come on, do it. This is, of course, we move things around a little bit, but as you remember beforehand, all the peaks that were exceeding the limits, now all we did is put this Word Design Your EMC filter in line, and you can see, even though it's not very sharp, there is not a single peak exceeding the limits. Now, to be fair, you would still do some additional attenuation here because you're way too close to the limit lines. Now, I should mention that this is not compliant with norms the way we did it there. But yeah, this is EMC 101. Just identify your problem and do something against it and know your limits.
Cool. Well, that's 101. I think you could do a whole course. We could do 102, 103. Not now, of course, but it is certainly something to think about, not just for hobbyists, but when you start thinking about putting your stuff out there, and it needs to be compliant. Let's take a look at some comments here before I want to ask Alfred about audio. Annie T says, hello, I love seeing other people's workspaces. Well, they are great. I'm not sure you want to see mine, but I'm envious of how much space Thomas has. And Alfred's workspace is very neat and tidy, but I don't know how much space he's working with. Sebastian, I've seen yours already. I brought this comment up earlier because it was relevant. David, KO4 USA, is saying that the wall warts, the power supplies that you plug into the wall, they're infamous for that kind of noise. And then, of course, from Carmine Abade, because he's American, can you remind us where each engineer is located? Sure, I know that I'm in Johannesburg, South Africa. Saad is in Islamabad, Pakistan. And the other three guys are in Germany, but I'm not sure exactly which city or if they want to tell us due to privacy considerations. Thomas, where are you?
I'm in I'm southwestern of Germany, directly on the French border. So
okay,
about 50 kilometers from Switzerland.
Ah, okay. Well, you've got easy access, kind of like Aachen for our Elektor labs. And Alfred, where are you located?
I'm located about 30 kilometers south from Stuttgart, close to the A81 to the Bodensee Lake Constance.
So both southern Germany. And then,
Yes.
of course, we've got Sebastian. And I don't think I asked you this before, but you seem to have quite a bit of nice space there, which is sure to please Annie T as well as others. Where is your lab located? Don't give us your exact address. We don't want any security considerations with all that expensive equipment.
Oh, I actually have security services here, so try me. No, I'm located in Kiel, Germany. So all the way up north.
Okay, so two southerners and one extreme northerner. And I would say I'm an extreme southerner. But the follow-up question from Carmine is, do they have any challenges in getting equipment for their spaces based on their locations? For instance, is it harder to source equipment in Germany versus other places? I can give my answer. I think it's pretty much easy. It's pretty easy to source stuff here in South Africa. Importing, there are a lot of importers and export. In fact, we even have Woord here. We've got Mauser, DigiKey. So it's not a problem in South Africa. How about the rest of you guys? I should say who should start. Thomas, you go, so we don't talk over each other.
Nothing is a problem to get anything what you want electronically. Even I get many things from China, meanwhile, because it's cheap, and it's no problem. You get it in a week.
Yeah, and that would, of course, apply to Alfred and Sebastian, same country,
yes,
same continent. Saad, do you have any challenges there in Pakistan?
Yes, a lot, to be honest. But if you plan it right, then it takes a lot of time in the shipping process, but you can eventually get the things you want. Of course, China is the first option to tick off and to try, but other options are available as well.
Yeah,
but time
China
is a big thing.
I've ordered cheap stuff from AliExpress, and it depends what you're buying. I would be skeptical of power supplies due to, the safety, the nature of the high voltages of that. I don't want any fires in that. I've also seen some people order large farad capacitors, which were just a case, and inside was a smaller capacitor of a lower rating.
That's
and
the classic.
I also ordered some chips, TMS9. You got one there.
I even got lithium batteries from China. So they're working.
Any good?
Yeah, they're good.
Do they work?
And I have a big battery. I don't know where it is. Really big one. Yeah, lithium battery.
So it's a mixed bag. You never know what you're going to get. I've ordered some chips like a TMS 9918 video generator, and I haven't tried it out yet, but who knows? It might be a fake.
Let's see.
Have you had any fakes?
This one.
Yes, a while ago during the chip crisis, somebody ordered.
I'm not going to make
analog devices, current probe amplifiers, and there was something in, but not the right thing.
You never know. And I'm probably, the amount of junk I order, I'm probably only going to find out when I retire if half of these things work or not, the chips especially. But we were speaking about audio with Sebastian and the interference that you get. And since we're talking test and measurement, specifically for you, Alfred, I'll bring this up on stage. This is a recent article of yours. It's an analog 1 kilohertz generator, which you generate sine waves with low distortion. Did you come up with that alone or base it on other ideas?
This is completely based on other ideas. So it's, I just made a prototype and changed it a little bit to get some point of perfection. But the basic ideas are years ago. So it's not my invention.
Cool. And
it's
got specifically low
only
distortion.
driven to the knowledge I have to get the best 1 kilohertz sine wave in the range of 0 dB volts with low THD. So this is a plot with 0 dB volts output made by maybe the best audio instrument you can buy, the Audio Precision APX 555, the old version, not the B version, which is newer. So you see the 2 kilohertz is around minus 130 dB, and 3 and 5 kilohertz are even less. And maybe there is some room for another 5 or maybe 10 dB to get it down. And it's...
Well, that curve already looks pretty clean to me.
Yeah, it depends. If you're used to work with the Audio Precision, is one stuff. If you're used to something in the hobby range, this is very good. It depends of your perspective. And it's hard, so I'm retired since a while. From the test and measurement perspective, it's hard if you were used to work with Keysight, Rode and Schwarz, Tektronix and others, perfect equipment, and then you're home with no more connection and a limited income, which decreased by being retired. And then it's a hard time then because I have a 8-bit scope, not a 12-bit scope. But
well, I better, thinking about that, becoming retired and having to not have such great equipment, I better start saving now. Because anything I buy now that's top of the range won't be top of the range in 10 years.
That's true. Hopefully there is eBay, so I got an older analog, or it's a digital video generator, but for analog video.
Nice.
So there was a famous company in the, was it the 80s, 90s, Magni, like Audio Precision. It's a spin off from Tektronix. If you look on their...
I wasn't sure how to spell that.
Magni.
Yeah, I'm Googling it as you speak.
M-A-G-N-I video. They were famous, but in the meantime, they are gone. They had a very good idea for a, let me say, to this time, perfect video generator, the 2015 and later the 20 and 21. And it costed, at that time, about the same as an Audio Precision 555 today. But today you get it for, let's say, $150 on eBay. Yeah, things like that.
Interesting. And I remember the Philips test pattern also from the 80s. And you and I could talk a lot about analog video because I did a lot in that field. But at the time, they also, besides the test pattern, when the TV channel was off, they also had a 1 kilohertz audio signal. I'm not sure how tone accurate I am, but I can hear that 1 kilohertz in my head, especially if you ever fell asleep to the TV and you woke up to the test pattern being on. I wonder what sort of signal to noise and harmonics they were achieving on those, because those were pretty high end at the time.
Yeah, I have no idea because I was focusing on the video and not on the audio. There were other colleagues working on the audio parts.
Okay.
And I was
we won't go into that.
Yeah, I was
continue.
Mainly working on videotape recorders like the old BCN 51 and the later stuff, real tapes like this, 1 inch tape.
1 inch?
1 inch, long time ago, all history, all gone.
Not all gone. I've got quite a bit here right at home of U-Matic and Betacam, and but I will not hog the time because I'm sure a lot of our audience does not need to know about test and measurement of old analog video signals. But always an interesting topic for me.
Unfortunately not. I liked it very much, but it's history. But audio is still alive, and also analog audio is still alive. Beside all the digital stuff, we have like streaming.
It's got to hit your ears.
Yeah.
No matter how digital it is, it's got to get to your ears in analog form. So there's always a call for low noise circuits. Got a comment here from Frank de Hert speaking about AliExpress et al. He ordered Hex 7 segment driver chips, 2 fake shipments, 3rd time good time. So it's like playing the lottery.
Yeah.
He says the 2 fake sets were remarked BCD drivers. Here's a good question. Short question. I'm not sure the answers will be short, but hit us. You Flip, what is the most useful tool each of you have in your workspaces any electronics engineer should have? I think, Thomas, you already answered that by saying a multimeter. And that's obviously the first thing I always reach for, but it's not the most complex thing. No. Sebastian says an oscilloscope. You can use it instead of a multimeter, frequency counter, etc. For you, Alfred?
Power supply, of course. If you have money enough, a spectrum analyzer is the next step.
Yeah. Or combined oscilloscope spectrum analyzer for normal use.
For normal use, if you use the real spectrum analyzer,
sure.
You like this more than the FFT function.
The choice is
again, I have just an 8-bit scope, so FFT does not look that nice.
Yeah. Well, it's
that's the right thing. You need multimeter, scope, probes, spectrum analyzer, power supply. That's, I would say, the basics. And generators.
Yeah.
Yeah.
Also with electronics, I think, with electronics, you also need a power profiler or something like that. I use Nordic for that to figure out what type of battery I need and how long it's going to last. But I've only got our hands on Joule Scope. And now I think I can measure lower till I think 1 nanoamp and for really good bandwidth as well. So it's pretty good to have these things on the desk if you're into battery-powered projects or similar.
And in modern times, using SMD devices, you have to have a hot air soldering machine. Absolutely.
I got one of those.
No. I have 2 of them.
Haven't used it much, to be honest.
But you need the tools, soldering tools, and all that stuff you need.
Yeah.
But that's, of course.
Did any of you miss, when you got a digital multimeter, did any of you miss seeing that the needle moving on the analog multimeter? I know I did for a little bit.
No. Don't do it. I don't do. I have older instruments and older power supplies with analog instruments, and I don't change that to digital ones, but to other digital ones. I would like to have it clear, even in my car. That's for speed.
Cool. Well, yeah, just something, some sort of feedback. I wouldn't say haptic, but something about having the meter and the slightest change. Whereas the digital, you never quite know the accuracy unless you have really good tools, which you guys clearly do. But Thomas, while you're up, let's get you up on Spotlight. You mentioned all your tools, and now I've put you in a big picture so that we can see your environment there. You have quite a few power supplies,
exactly,
including a very old one, I understand.
Yeah, you first, please, you could show the picture of my workbench.
Sure.
Please. Yeah, there you can see the parts I'm normally use, the most important things I use. I have much more than this, but I can put all on the wall. And there you can see from right, you can see several power supplies. The right one is a high power 12-volt power supply for a micro drill like that. See that? It's even important if you are an electrician to have drilling some holes.
Like a Dremel.
Yeah, like a Dremel, but faster. And then there is a very old, the second from right, is a very old, 44 years old power supply built around an analog laser trimmed chip. It's called L070, and it has a precision of about, I think about 0.1%. And I even just measured it. No, I can show it. Just change the video source. Second, please. So I can show it to you. You see here the power supply. I put it and 2 volts. And you see what my desktop multimeter will show. You see, not exactly 0.1%. It should be only an error of 2 millivolt, but it has 3.6 millivolt error. But this is an error of the instrument, of the measurement instrument. The digital multimeter is not calibrated. It has a factory built accuracy, and it's not enough. But I have a calibrated one, this one, an old one, and you will see. You see, less than 0.1% after 44 years. This is ultra stability of an analog IC or integrated circuit. I never saw that like that, so stable. So this is one of my
measuring analog signals.
Yeah, measurement 2 volts. The 2 volt are from this power supply.
Yeah, I'm impressed that my 43-year-old digital computer still switches on, but you're getting that accuracy to 1% after 44 years, you say? That's incredible.
Yeah, it's incredible. And I use it to calibrate my circuits when I just have to measure something. And the next power supply, this a power cheap, a high power supply, 60 volt, 10 amps or 15 amps, 8 amps. Yeah, I see. And the smaller one, so with 3 amps and so on. And this is an isolation transformer I built with 2 separate transformers. One is transforming down from 230 volt to 24 volts. And then the next one is transforming it up with 100 watts. But in some cases, when I experiment with net voltage with 230 volt, I need high impedance power out. And then I put a resistor in it, and I can switch it on and off. So I have a high impedance and a low impedance output here, which helped me not breaking the fuse of my home so often.
Cool.
Then what you see here, many multimeters here, signal generator, scope, different soldering irons for different purposes, and so on. So first impression.
That's great. And which of those power supplies was inspired by Elektor?
This one, the first one, was published in 1980 And when I first started work at Elektor, I saw this possible. I built it immediately. You see, it's very old, and my mechanical skill are not so high in these times, and I have not so much equipment than I do have now. Because I was very young.
Well, that's great. I'll have to go back and have a look at that article from the 80s in Elektor. To remind it to our audience, if you are an Elektor subscriber, you can go back in the archive and find this stuff.
Yeah, I type it in the comments what it is. So go back.
Cool. There we go. You're back on stage, Thomas.
I see. Oh, 07.
While Thomas is typing in the comments, Frank De Hert says, angular grinder drill press. Yeah, if I knew a little bit more about mechanical engineering, that would be great. But currently, I'm mostly about electronics. Mike says, for embedded, I rely on logic analyzers quite a bit. Yeah, I've got some cheap ones, USB-based with about 8-bit input. Useful, and back before I could afford logic analyzers, and you didn't get really cheap ones, I used to use a PC parallel port, and the maximum I could sample was about 400 kilohertz using the fastest assembly language I could. Jack says, okay, I'm jealous of these great workspaces. You have all inspired me to clean mine up. You and me both, Jack, you and me both. My space is limited and I'm using it for studio, office, lab, you name it. And yes, Jack, Brian is a living tech museum. Sounds like he has much great retro equipment. Yeah, I could get up now and open the cupboard behind me and show you my VHS, Betamax, Betacam, U-Matic. I've even got a 1-inch tape of a music video. I've tried to have all the different formats as well. Digitizing them, that's difficult. I'll have to have Thomas Scherer or Alfred Rosenkranzer help me to align these things from the 80s, because a lot of them will need new belts or won't work. Sebastian from Baltic Lab, we've heard of him. He says he wouldn't claim that his bench is particularly well cleaned when he doesn't have a scheduled live stream. Yeah, everything is tidy within the camera view.
Yes, don't believe anything that's on the internet.
Exactly. And Thomas, your comment, PSIC L070.
Yeah. Okay, like that, this saying, I would say, don't move your finger if you work on a HF electronic part.
Yeah.
Because of changing
that.
Yeah. And if I want, I can show what I'm working on in the moment.
Yeah, please.
Okay.
Let's put you in the spotlight again.
The camera again. Yep. You see the next version of a data transfer unit for microinverters for balcony power plants. This one has 2 HF modules on it. No? This is a standard one for the older systems, which works on 2.4 gigahertz, and on the side you see the smaller ones underneath, which works on 833 megahertz and has a much wider range. So I can have it here from my cellar through several walls and still reach my microinverter through the air. And this is another one. There's only, you can see the new HF chip. And maybe in some months, I will publish it in Elektor. It's still working.
Well, that sounds. Well, your most popular articles have been optimizing balcony power plants. So I see you're still working on that. And of course, they have been particularly popular in Elektor and quite popular, especially in Germany. There seems to be some fascination in Germany with solar power plants for the home.
Yeah, we have, and this year we have more than 250,000 new installations of balcony power plants. And even friends of mine are asking me, because I know I'm an electrician, so can you help me put it? And so I have several weekends climbing on roofs of friends and installing new panels and so on.
Nice. Yeah, I told you a friend of mine has a completely off-grid system here in South Africa. The grid is optional, but he never needs it. Doesn't matter how overcast or if it's raining. And that itself could make a good Elektor article.
Yeah, this is
fortunately has the space.
And what I will prepare next is my Bicony power plant with own battery. Wow, you see how heavy it is, with about 20 kilograms.
200 amp hours.
Yeah, exactly.
I do have an inverter here, and it's got a couple of those huge batteries, but there's no solar. It just backs up the grid power for when we lose power. Did you say you ordered that from China?
Yeah, I did. So
Okay.
it was very
I
cheap.
thought shipping batteries was a nightmare.
350 euros with shipping for this battery.
And then I just wanted to say that while you were showing me your workspace, I also have a tool that you have. So I'm proud to have something that even the professional engineers use.
Yeah, very, very useful, because all the screws and the little parts thrown around, and it's electrically isolated, not only a desk surface, so you can put your boards directly on it and measure them and let them work. No? It's
it's a change from the old days of working on kitchen counters and having all the screws roll off the edge.
Yeah. And then you get on some contacts, you get some signals from your hand and so on.
Brian, speaking of reminiscing about the past, that reminds me of the giveaway.
Well, that, I'm not that forgetful. That was the very recent past. That was less than an hour ago, but good points. I'll bring that up now. We did tell you about our giveaway earlier, and that's the giveaway page. We'll get the URL up on the screen shortly, but this is what we're giving away, as I said to you earlier, Tektronix Epic Oscilloscopes book, and it's great. It's gloss, it's heavy, it's a very pretty book, and you have to go to our giveaway page and enter the code word. The code word this week is testing 1, 2, 3. It's appropriate for the topic of today's show. And go to our giveaway page at Elektor webinar giveaway. I'm highlighting it there, but it's a bit small, so I will get it up on screen here. There. Now we can remove the screen sharing. So go to that web URL, enter testing 1, 2, 3 as neatly and as cogently as you can say that, and then the one who types it best gets the prize, or all 3 prizes. Going back to the comments. We've got a lot of comments from Elektor TV helping with the code word and the URL. Annie is back saying she likes the energy projects like Balcony Power. Inside your energy meter, very interesting. Yeah. That means Annie's a reader, because we haven't gone much into the energy meter, but Saad has quite an interesting project unrolling over several issues.
I mean, it's been 2 months now. It's installed, and it's been really helping me know which AC is on and who's overusing the energy in our house. I'm also thinking about installing it next to the solar inverter, so that I can understand how much I'm exporting, because some of these solar inverters do not give you the exact current and kilowatt hour produced as well. So it's a work in progress.
And also ESP32 based.
Yes, of course. Yeah. I mean, it's easier to do anything with it.
Yeah. It's now ESP32 is a tool for everything.
Yeah. Why do you need so many power supplies, Thomas? Is one not good enough?
Yeah, because sometimes I have high power equipment, especially if I have it's a motor driver, high power motor driver. I worked on, which has about 2 kilowatts, and so you need a high power supply, and you have some special voltages. I have this old one, this very stable one, and then you need more than 1 voltage. I think typically 2 is normal, 3 is better.
Okay.
And
I thought you were holding a Bitcoin miner there for a second.
Or 5, I think. Even several volts. You can't have power supplies enough.
Well, we've just gone up on 1 hour. It's now 5 p.m. in Europe and other times elsewhere. So I'm not going to interrupt our audience. If you want to leave, you can leave. If anyone objects, we can go on a little bit longer. Then that's cool. Everyone agrees. We'll carry on this interesting conversation. You also have some other interesting tools, Thomas. You have a contactless temperature reader, which I saw there. How often do you use that?
Temperature reader. Yeah. It's for checking if something is wrong on a circuit, no? Especially if you have a power things, you just use it to look. Oh, it starts where it's too warm or so. No, you see. Oh, I see. You can, you can see the laser spot. No, not really, but on my finger you can see it. Yeah,
I can see it. Yeah,
I'm alive. 29 degrees. So. You can exactly check where it can get too hot, or if an integrated circuit uses too much power and something like that before it makes some noise and cracks.
So I had something similar, but it was cheap and it was designed for COVID, so it was useless for electronics. It only went from 32 to 40 degrees.
Next thing I would buy, if it's not too expensive, would be a temperature camera, which is much more useful.
Yes. Yeah, we have an article about that in our recent edition of Elektor.
No, I will build it myself, I think.
Written by me, by the way.
Yeah. So, hello.
Well, I'm definitely going to put it up on screen.
Yeah, you just
looking
need
at the comments,
a few €100.
Yeah,
that's always the
only.
I think 800,
especially for as you.
But that's a very cheap, low resolution solution in the last Elektor issue.
Yeah, it's a nice toy.
Yeah,
but not much more.
Yeah. For me, maybe enough. I don't know. I will build it, and then I will will tell if it's enough. What I have two different Feldstärke-Messgerät. Yeah. Some older measurement equipment, Feldstärke-Messgerät, field strength meter.
Feldstärke-Messgerät, yeah, okay.
And
wow.
Yeah, what?
See, I'm not the only technology museum out there.
Yeah, I have many of all these detectors, yeah. And even the battery soldering iron. So something
I've got a gas one actually, which I use for out in the field. I don't think
battery ones. If you're soldering for 10 minutes, it's in battery.
Well, another one from Carmine. Was there a special thing that led each of you into engineering as a youngster? For example, amateur radio or robotics kits?
In my case, I got when I was 12 years old, I got at Gressman, I got a kit for experimenting with electronics, and I could build my first radio with an AM receiver. No? So, and it worked. No?
Yeah.
I was so surprised about myself. No? Showed it to my father. Look, I can build a radio. He said, I have a radio board. It works too.
Yeah. Well, I did build the crystal radio set and it never worked. So I never got that excitement that you got.
Yeah, I get it working.
And how about you, Alfred? What made you start out in engineering?
I also started with this famous Philips electronic kit, and it was fascinating me. So it was very clear from, let's say, age 13 that I'm going to be an electronic engineer, and always in the design area. Never marketing. Don't put me to marketing. That's okay.
Yeah, I've been all over the place like a ping ball, but I always come back to electronics. I even tried chemistry once. I had little spice bottles in my bedroom of sulfur and saltpeter and used to make gunpowder and that sort of thing.
Yeah.
Now, looking at the youngsters in the bottom part of your screen, Saad, what drew you into engineering?
Well, first of all, I was into more mechanical stuff. My dad is a aviation engineer, so I was into more airspace stuff like drones and aircrafts. But then I saw Iron Man. I was like, okay, robotics is the way to go. And then then I joined the mechatronics engineering in my university. And since on then, I'm just into the embedded, and I'm really happy with that decision.
And Sebastian?
Well, it was a combination of, do you remember, I think they're a German thing, those Cosmos electronic kits.
Yeah.
Yes, I see nodding from the German audience. I got those very early age, I think 6 or 7, so way too early. And I remember one of the first things it said in the book is to never connect an LED to the battery without a resistor. So what do you do at that age? Hook it up. And back in the day, the gas charge pressure was so high that the cap would fly off. So I bought another 100 of those from Conrad Electronics and did that about another 100 times. But in general, it was radio frequency in all kinds of facets, building my own radio receiver, possibly building my own radio transmitter, though, of course, that wouldn't be legal, and things like that. It's always been that. It was very frustrating on one side because, as you can imagine, as a kid or as an early teen with radio frequency and no proper test equipment is kind of hard. On the other side, the happiness and contentment when it finally did work really kept me with the hobby and trained me to, instead of looking at short-term success, look at long-term success and appreciate that.
Yeah, and I envy you guys with all of your analog skills as well. Inside, I can say I also loved robots as a kid. Any toy robot I could get, and they were usually crappy. And also, you know, I was a big fan of Kampfstern Galactica for you Germans, but Battlestar Galactica when I was a kid in English, and they had walking, talking robots, and they would go Battlestar Galactica approaching. And so I was very into speech synthesis, and I was trying to build a RS-232 text-to-speech, you know, pretty much like Stephen Hawking's voice. I was always interested in that stuff. I just never got the skills to get the mechanics right. I can do the digital stuff, but my robot, unfortunately, just will sit there and not go anywhere.
Yeah, exactly.
Comment from Manuel Caldera. Started with a similar kit in SA at age 12. By SA, you might mean South Africa, where I am, but, you know, it could be South Australia. Once I had a post sent to RSA, and it went to the Republic of Saudi Arabia, so never know. But cool, thanks for that, Manuel. And then I also wanted to touch on something with Sebastian, but not too long since we're over time. But you did have a centipede kit, precision probing.
It's a PC Bytes kit.
Okay.
Let me swap the camera around. Don't get dizzy. Let's see if the cable is long enough. Yes.
Nice.
Let's switch that off first. Get the light on the side. All right. Well, could frame this better, but we are already into overtime. So what this is the PC Byte kit. It has a few standoffs on the bottom where you just clamp your device on the test in. Unfortunately, this webcam is not gonna focus very well. Put it down there. Okay. Well, we're gonna have to live with that. So these clamp in. As you can see, you can pull them down and pull them off. So your PCB is in place and will stay there. Even though this one probe just fell down, they're usually very well in place. Does it focus on that? Well, here are some probes. This is one of them, which is for DC probing, and I won't poke this too hard in my finger. But the tips are actually, let's switch the screen. I'm not happy with that. Let me switch the camera source, and then we'll look at the end and star.
If you're going to play with that probe, you could do a blood glucose test while you're about it.
Yeah, I don't want to look at my finger because I already poked it too hard, so I could probably do that, but I don't have any test strips here. Let's see. Yeah, there we go. Okay, cool.
Nice.
So that is a very dusty board. Let me get it into place. There we go. Just for comparison, this is my thumb.
Oh, wow.
Okay. So this is
my thumb at that.
This is a 10 MSOP casing. This is an 5351, obviously I forgot the prefix, SI5351. This is a 3-channel PLL. And if you want to probe something like this, and you just stick your usual oscilloscope probe in there, most likely you're going to short something, and even if you hit just the right spot, you're not going to be able to hold it there very well. Now, if you take one of the PC Bytes probe and be a bit patient, if I can get it on there with my, go on there. You know, doing this through a digital oscilloscope, this is a bit high. There we go. Let's take that one. Do it.
You got to cut down on the caffeine.
Yes, that's what I was thinking. There we go.
But cheers anyway.
Yeah. Even it worked.
And that is really neat. It'll stay there now. You have various different options for hooking up ground or leaving out ground. Generally, it's DuPont connectors. So let me switch to the other camera. There we go. Although this is not as pretty. Let me do it like this. There's various different ones, like the one I had here. You can hook it up to a multimeter. And they are pretty heavy, these prongs. So they will stay in place. If you put them on, no, I do not want to probe my finger. If you just stick it on there, you see it's springy.
Oh, yeah.
And it will stay there. Like even if I, do this, it will move, but it'll stay where it's supposed to be. And this up here is DuPont connectors. So you can just make your own extensions, put it up to a logic analyzer, use a BNC or SMA adapter. And one thing that's never been talked about on the internet that I want to mention, I mentioned EMC compliance norms and rules and regulations earlier. And one of the test setups, most of them require that you have a conductive base plate, which this is. These are magnet mounts. And there's a standardized height between the base plate and the device under test, which is, according to CISPR 25, 5 centimeters plus minus 5 millimeters. You won't be able to see this. It is just slightly higher than that. And I think PC Bytes never had this in mind, but it is actually perfect for doing pre-compliance tests as a hobbyist at home. And definitely a good choice for not destroying your circuits when you're trying to probe around.
Awesome. I like the tactile look of that. I wish I could feel it the way you say it's springy.
Well, Elektor can help you with that because it's actually available in the Elektor store.
To get it here, though, I'm going to have to pick one up when I'm there in November. Comment from Carmine is the Armortron. You must have heard my Battlestar Galactica comment. It's from Tomy, one of my favorites. Even that would have impressed me as a kid. Just a robot arm, something that you can make move from your computer. Even if I could just, switch off the lights on and off, but physical computing, making something move. I never got to that stage as a kid, so my dreams were shattered, unfortunately. But, at least we're still pursuing the same avenues of interest at the moment. We are running a bit late, and there were many topics that we didn't touch on, but that's what happens when you have such great guests. And Sebastian, you can change your camera so that we can do a farewell. We've got Thomas and Alfred from southern Germany, and we've got Sebastian way up north. And, we could have done a 2 or 3 hour show. I'm not sure my voice could have handled it. Alfred didn't speak too much because he has a bit of a cold, so I wouldn't want to torture him more than that. And I know where Saad is, it's 3 hours later than what it is here. So I just want to thank you guys all for joining us. 14 minutes over, I think that's some kind of a record. I'm glad that my colleagues were patient enough to stick around with me. Thank you. We'll start on the top left. Thanks to Sebastian for joining us.
See you next time. Always fun to join.
Yeah, and thanks for your illustrative insights. And we will get some more of that in the future for sure. And Alfred, thanks for joining us with your cold. I hope the jersey is helping you.
Yeah, I hope so.
Cool. Okay. And Thomas, always great to see you again. I think I need to come visit you guys in person because you have amazing workspaces. And me, not so much, but, you're inspiring me.
So next time when I come
not
to
ready.
Africa, I visit you.
Yeah, looks
bring your
like
lab,
a
I want to see
TV museum with all of the old stuff I worked on long time ago.
I'd be happy to do a show about that. I'm not sure it would be the most popular with the current audience or anyone born after, say, 1995, but still would be a great show for me. And Saad joining us all the way from Islamabad, where it's a bit later than here. Thanks for staying up late for us.
Thank you, Ryan. It was nice to be here.
Cool. Not that it's that late, but anyway, thanks for working overtime in any event. And to our audience coming to us all from around the world, and Manuel has confirmed that he is from South Africa, Peter Maritzburg. Thanks for everyone from around the world for joining us. And for the Elektor team working in the background, Alina, thanks for pressing the buttons when they needed to be pressed so that we could get this done successfully. To those of you who entered the competition, good luck. That looks like a great book. I don't get all of the Elektor products, especially something as heavy as a book. Shipping would be prohibitive, but I try and stuff my luggage whenever I go to Europe. So good luck with that. We've got 3 of those, and we hope you win. And until next time, thanks very much for joining us, and we will see you at the next webinar, or you can actually join us for Electoral Engineering Insights later this month, where we will meet Sam from Look Mum No Computer. Just visit our website and you'll get the YouTube links and everything that you need there. Thank you, and good night, good evening, good afternoon, good morning, wherever you are.
Bye-bye.
Good night.